Time and the events that occur within it do not stand still. Many things that were once considered acceptable, desirable, or fashionable become inappropriate, ridiculous, or completely irrelevant as the centuries pass. These metamorphoses can be traced by studying the history of cinema, from the black and white footage of Charlie Chaplin to the super-technological, three-dimensional scenes of Avatar. Changes are also evident in the evolution of navigational devices, from the compass, sextant, and astrolabe to modern GPS navigators. Astronomy was not spared. In particular, ideas about certain celestial bodies have changed dramatically over the centuries of research. What would you say about Pluto, for example, once the smallest and most distant planet in the solar system? Today's school children, especially those who pay at least some attention to their lessons, are now twisting a finger at a temple because since 2006, the planet of that name no longer exists. No, Pluto itself has not disappeared, but its status has irrevocably changed. Let's take it from the very beginning. Pluto is a small celestial body, first discovered in February 1930. Although its existence had been speculated about many times long before that event, be that as it may, the dwarf object was discovered by Clyde Tombaugh, and since then there have been constant attempts to learn as much as possible about Pluto. By the way, the planet could have been called something completely different, Percival or Zeus, but Venetia Burney, a schoolgirl from Oxford, rightly decided that the name of the Greek god of the underworld was best for such a cold and dark world. What is it? The distant and virtually unexplored Pluto. Given the object's remoteness and the fact that its year is almost 2.5 Earth centuries, it is extremely difficult to study the planet. It is a very cold and unfamiliar world to us. Its dissimilarity is evident in literally everything, from its strange, highly elongated elliptical orbit to the several types of thick ice that make up 70% of the object. Pluto's size is negligible. It's even smaller than some of its satellites, Titan, Callisto, Io, and even our moon, which is 6 times the size of the object. And this is despite the fact that it has a satellite of its own, the mysterious Charon, the coldest celestial body in the solar system. Pluto has 4 other companions, Hydra, Nix, Kerberos, and Styx, whose names are also associated with the underworld. The area of Pluto is minuscule. It is slightly larger than the size of Russia, only a few 100,000 square kilometers. The icy crumb has its own atmosphere, albeit a very thin, rarefied. And the only Earth vehicle that saw the object up close was the New Horizons. It would seem that we have a classic planet in front of us, but 14 years ago, there was an event that greatly shook the authority of the celestial body and expelled it from the honorary cohort of members of the solar system. On 24th August 2006, the International Astronomical Union gave a clear definition of the term planet for the first time, after which Pluto lost its title forever. At the conference, the following criteria were announced. The body must be massive enough and have gravity that allows it to take a spherical shape. Pluto meets these characteristics, doesn't it? But listen up. The second criterion is rotation around the Sun. This point is also unquestionable. The third condition requires that the body not be a satellite of another planet, still passing here. But Pluto was badly let down by the 4th clause announced by the IAU, because according to it, the celestial body categorically does not fit the definition of a planet. The fatal condition implies that the object must clear its neighboring region of other objects. But how can this be done? During the formation period, a body must unquestionably dominate the orbit around its parent luminary and prevent any serious competitors from being there. To get rid of them, the object either absorbs smaller bodies or pushes out those that are larger. The result is a conquered space and quietly follow the beaten path. But near Pluto, on the contrary, is full of bodies from the Kuiper Belt, which, according to the most modest estimates, inhabits more than 70,000 celestial wanderers. Sedna, Makemake, Haumea, Erida, incidentally, which has its own satellite Dysnomia, Orc. All of them have approximately the same mass and composition with Pluto, and therefore, most likely one of them. This is the main reason for the expulsion of the cute dwarf from the planetary ranks. I wonder if Pluto has any other choice than to be branded an underplanet. It turns out that the shame can be washed away. How? Very simply, it is enough to mercilessly absorb its neighbors and remain in proud solitude. And then, welcome to Club. By the way, Erida also applies. After the discovery of Erida, which is 25% heavier than its divine neighbor, there was a debate about which group the spherical object should belong to, perhaps to the planets of the solar system, by analogy with Pluto. But the disagreement among scientists was resolved by the IAU General Assembly held in Prague in the aforementioned 2006. It was decided to exclude Pluto from the number of planets, although not everyone still agrees with this. At the event, initiated a vote for a specific list of criteria, and one of the options, if it passes on the votes, would have increased the number of planets in the solar system to 12. The list would have included Erida and Ceres. But the scenario of the conference went as we know now. And now let's talk about the counter-arguments, because not everyone agrees with the conclusions drawn by the majority. If you remember, there was even a wave of indignant rallies on Earth. First of all, many people do not understand why to create an artificial problem and come up with absurd definitions. Secondly, if we touch upon the decoding of the term, some professors believe that all the criteria mentioned above work exclusively in the conditions of the solar system and are valid only within its limits. So, in fact, this is not a definition of the term planet, but a clarification of the concept of planet. Active scientific movements around Pluto created a lot of excitement and multiplied the popularity of the modest object. But not only these events have left a trace in history, the discovery of the celestial body has generated a lot of illusions. For example, it is said that his name is named good-natured and goofy dog Pluto from the Disney cartoon, released 6 months after the discovery of the dwarf planet. And in 1943, the American chemist Glenn Seaborg called the newly discovered element plutonium. Undoubtedly, the macrocosm surrounding us presents the greatest number of mysteries. It is not easy to solve them, but nothing prevents us from developing a series of hypotheses, more or less close to the truth. You will agree that to this day, despite the knowledge and technology at our disposal, some questions remain difficult to answer. For example, how big is the universe and does it have boundaries? Progress does not stand still, so soon our comprehension will be significantly enhanced, because a new generation of telescopes are coming into action, confidently opening the doors to the vague past of the vast universe. More recently, people have been able to view the world in ways that go beyond the capabilities of the orbiting Hubble. 2 years later, the world's most powerful infrared observatory, called the James Webb Telescope, went into operation. Thanks to this unit placed into orbit, we are able to find exoplanets, observe the formation of galaxies and the birth of stars. Additionally, HabEx is being prepared for launch. It is designed to search for super-Earths and can block out the bright light of stars. The X-ray Lynx is also being developed, with ultra-sensitive detectors to identify locations where black holes form, and the OST with a huge 9-meter mirror and hardware 30 times more sensitive than James Webb's. Thanks to recent technological advances, we can now examine Proxima b, which is located near the star Proxima Centauri, 4 light-years away, as well as Kepler 16b, the prototype of the legendary Tatooine. Moreover, astronomers will be able to see the Satan's eerie lair, the Ko-Ro T7b, a planet with a hemisphere that is constantly raining rock. But let's think about another interesting question. How can a person who is used to the pygmy scale of Earth understand, let alone measure, billions of universal kilometers? It is extremely difficult for Earth inhabitants to imagine the location of the aforementioned planets, where life may exist, and their distance from us. So let's have a little enlightenment. What units are commonly used to measure distance in space? Within our solar system, it's done in astronomical units. An astronomical unit is equivalent to the average distance between the Earth and the Sun, which is 150 million kilometers. However, once outside the star system, it becomes extremely inconvenient for scientists to count dozens of zeros, so such a unit of measurement as the light year comes into play. It includes the distance a photon of light travels in 365 days. With a little rounding, the speed of light would be 300,000 kilometers per second. The result is a huge number with 12 zeros. Given this information, it's scary to think how far away from us is, for example, Proxima b, one of the closest exoplanets found. This information is able to activate the imagination, but a clear realization of the scale of the mentioned distances has not come. So let's try to measure the annual path of light in the usual equivalent human steps. It sounds strange, but try to abstract and visualize what we will talk about next. For example, by performing basic calculations, you can determine the following. If a person moves continuously at a speed of 5 kilometers per hour for a year, he will cover a distance of 43,800 kilometers. Now, let's take the average life expectancy of 68 years and multiply it by the above figure. We get 2,078,400 kilometers. That is, if you walk your whole life without stopping, you will have traveled only about 9 light seconds. Think about it. Man will not even reach Mars. But, as you know, one is not a warrior in the field, so let's calculate how many kilometers the Earth's population will travel, dividing into pairs and alternately every 68 years, passing the baton to the next tandems. The figure is much more tangible: 11,319,371,410, 6,800 kilometers. As you can see, that's even more than a light year, but it would take the entire planet millions of years to walk. Now think about how many people and time it would take to walk to, say, Alpha Centauri b, which is 4.4 light years away. And if you try to cross the Milky Way, which is 100,000 light years across, does it make your hair stand on end? Then don't even bother trying to calculate the man-hours required to pilgrimage through the largest known galaxy with a diameter of 6 million light years. We can say for sure, the efforts of all the people who have ever lived on Earth, which is about 107 billion people, are not enough. If the distances to individual members of the stellar planetary brotherhood are so enormous, how enormous is the universe itself? No one living on Earth is able to say exactly what its dimensions are and whether the macrocosm is finite. But one indisputable fact is known. The sky, which we look at every night, is a kind of video recording. In other words, an excursion into the past. The only question is the time. Sometimes it is only 8 minutes, as in the case of the Sun, and sometimes it is millions and billions of light years. That is, that shining point you are looking at now may be a galaxy that died many centuries ago, but the light from it will be traveling along the universal paths for a long time to come. For dessert, let's raise one more actual problem of cosmology. Behind what line of macrocosm we cannot look, and what objects we can observe relatively unobstructed. It's known that the boundary of the observable universe is about 45 billion light years away from us. That's an incredible amount of light years away. But what lies beyond that horizon? It seems that mankind will not open the veil of this mystery for a long time. By the way, it is worth mentioning the hypothesis of stable expansion of the universe, often discussed in scientific circles. It is accepted that it happens evenly in all points at once. So it is impossible to understand where you are now, in the center or on the periphery. So the horizon could be moving away over time. And then, it is unlikely that even in thousands of centuries there will be telescopes capable of looking beyond the invisible boundary of the titanic bubble and see what is hidden in the inky darkness of the cosmos. And of the optics that exist today, neither Hubble, James Webb, OST, nor Lynx are capable of doing so. Fortunately, there are so many interesting objects around us that will take generations of astronomers to study, that it's very tempting but unproductive to think about the boundaries of the universe. If you are interested in this topic, then write in the comments your variant. Perhaps you adhere to the version of multiverse with alternative laws, or believe in a boundless and flat macrocosm. Looking upwards, astronomers have been observing ordered star systems and galactic algorithms for centuries, never deviating from the plan for a second. But in the depths of the macrocosm, there are objects that do not fit into the framework of schemes and rules. They float in complete silence and darkness, occasionally interrupted by the blinding light of stars. They are eternal wanderers of the universe, unable to find a shelter in any of its corners, the rogue planets. Since the early 90s of the last century, there has been a hunt for space nomads. As a result, astrophysicists found about 100 billion orphan planets in the Milky Way alone. The object's primary feature is its lack of residence in any star system. A rogue planet orbits a galactic nucleus or travels through deep space without gravitational binding. Independent quasi-planets come in three types: rocky objects, gas celestial bodies, and brown dwarfs. The first is super-Earths. It is believed that they constitute the majority of the rogues. The mass of an object does not exceed 10 Earth masses. Nomad gas giants can reach 13 masses of Jupiter and share a similar structure. The third type of rogues are formally classified as stars, although they are actually planets. These are brown and sub-brown dwarfs. They are heavier than the upper mass limit of gas giants and do not reach the minimum mass of stars. Therefore, it is impossible to start nuclear reactions in the interior of brown dwarfs. Failed heavenly bodies are formed from interstellar gas clouds compressed by their own gravitational forces. Astronomers do not believe in the autonomous formation of wandering planets. They believe that Earth-like and gaseous celestial bodies are initially formed in stellar systems. However, after surviving a cataclysm, they can decay from orbit and enter free flight. What does the unknown world of rogue planets look like? Is life possible on its surface? Theses based on computer modeling do not exclude such an option. Super-Earths are the most entertaining of the three types mentioned and are potential hosts for extraterrestrial life. The hot core will keep the oceans from freezing and keep the planet active, preventing the celestial body from turning into a useless piece of rock. Among other things, proponents of the optimistic scenario cite Europe as an example. Frozen moon of our gas giant under the centuries-old thickness of ice supposedly hides an inhabited ocean. So, rogue planets may well be surrounded by habitable moons similar to Europa. Except it's useless to look for dolphins or giant stingrays in their waters. The energy of the neighboring planet is enough only for the emergence of microscopic colonies. Scientists say that the mechanism of tidal forces of gas giants can work on a long-term basis. The temperature will begin to decline only as radiation resources are exhausted, which is tens of billions of years. Moons are also capable of feedback. If the masses of the satellite and quasi-planet are roughly the same as those of the Earth and the Moon, the latter will constantly stimulate the former, periodically cheering it up and activating geological processes. An interesting idea expressed David Stevenson, a professor at the California Institute of Technology. Scientists believe that such sources of life as wandering gas giants should not be dismissed. Let's illustrate the theory with the example of Jupiter. The temperature of its core is about 20,000 degrees centigrade. Consequently, in the thickness of the atmospheric layers is sure to find a zone where the thermometer will show about the same as on the surface of the Earth. This will create the conditions for microorganisms to form. And it doesn't matter that the gas giants don't allow them to land. Bacteria don't require that. They may well live on the surface of the aerosol particles of a rogue planet. And the last assumption, the oceans of space wanderers are real candidates for the habitat of living organisms, by analogy with terrestrial geothermal sources. At their bottoms can develop a whole ecosystem based on fossil resources and underwater volcanoes. It's practically a paradise for protozoa. On top of the ice dome, reliably protecting from unfavorable external influences, and below is a warm planetary furnace. But if a representative of intelligent life from the outside were to find himself in such a place, it would seem to him a hellish ice sarcophagus, from the bowels of which there is no way out. The further destiny of such living corners, senselessly flying through the vacuum wasteland, is sad. Sooner or later, the planet's core will cool down, the ocean will freeze and bury the creatures living in it forever. The most unfortunate thing is that all the generations once born and dying in this subglacial realm will never know of the existence of a larger universe beyond their own microcosm. Soon, interstellar travelers will no longer be invisible. The microlensing process has been perfected, and Earth scientists are detecting outcasts more and more often. But if such a visitor flies into the solar system, catastrophe cannot be avoided. The planet would disturb comets in the Oort cloud, and the Earth could be sprinkled with deadly rain. The hunt for rogue planets is a pipe dream for the average citizen, but look at them at least through the eyes of our channel. Subscribe, comment, vote with likes. Avalanche of interesting releases is on the way. Comments from the previous video.